Hi, Math 206 students. We have already discussed side congruence, and now we'll discuss side angle side congruence. So what side angle side says is if you have two triangles where you have two sides of one are congruent to two sides of the other, and the angle in between the two sides is congruent to the angle in between two sides of the other triangle, then the two triangles are congruent. And this comes from the fact that we're able to construct a triangle congruent to a given triangle by constructing two sides and the angle included. So let's go ahead and use side angle side to construct a triangle that's congruent to the given triangle. All right, so step one will be to indicate a point for the vertex congruent to vertex A. And then I will use my compass to copy the length AC over. So I'll make a marking here for the length AC. And I will also, I'll draw in a ray emanating from A prime. So there's the ray, and then this intersection point here will be C prime. So now I know that this length, this side, AC, is congruent to this side, A prime, C prime. So that'll be my step one here. Step one was to construct A prime, C prime, which is congruent to AC, okay? The next thing that I'm going to do is, just like we saw in the last construction, I want to copy this angle over. And the way that we do that is set our compass to any length, make an arc out of vertex A of that length, and copy that arc over starting from vertex A prime. Okay, so this is this one here was step one, and this here is step two. Step two is to draw an arc from vertex A and copy the arc over to A prime. All right, step three now is going to be to find the distance here between this intersection point and this intersection point. And let me give these 2 points names. Like, let me call this, say, alpha for this intersection point and beta for this intersection point. So I'm going to measure that length, and I'll come over here and put my compass at the intersection of the side and the arc, and then I'll draw another arc to indicate that copying this length over. So this is like alpha prime is right here, and here is beta prime. So step three, where I drew this arc, is to measure the length, the distance from alpha to beta on the first triangle, and draw the arc over from alpha prime. All right, so now I have this intersection point, and I can draw in the ray emanating from A prime. The last thing to do now, I have two vertices of my triangle and the other side, so I know what this angle is. So now I know that this angle is the same as this angle, and this side is the same as this side. Last thing now to do is to measure the distance from A to B and then copy that over on this ray so that I know where B prime is. So I'll use my compass to do that. Set one side of the compass to A, the other side to B, and then copy that length over from A prime. So that intersection is now B prime, and I'm done. So this was here step 4, which I'll write down here. Step 4 was to measure the distance from A to B and copy over the, from A prime to create vertex B prime. And of course, the very last step is to connect the last two vertices of this triangle, B prime to C prime. All right, so there we have it. We copied it over using side, copied over the side, copy the angle, copy the other side. So by side, angle, side, these two triangles are congruent. Now we can go through that construction one more time, a little bit faster now that we've gone through the entire explanation. So let's go ahead one more time. Let me erase my markings here that I made on the original triangle. Step 1, construct A prime, C prime. So I'll, step 1, measure this distance from A to C, copy that over here, draw a ray coming out of A prime, and at this intersection point, I've got C prime. Step 2 is to copy the angle over. So I'll set my compass to any old length that I like, and I'll draw an arc. This one I'll make a little bit bigger than the last one, just because it doesn't matter. That gives me these two. I'll call that alpha and beta. And I'll draw that same arc over here. Here's alpha prime. And then in order to find beta prime, let's measure the distance from alpha to beta and copy that over. Alpha prime. There we have beta prime. So again, this last step, I just copied this length over to here. All right, let's draw in the arc, or the ray coming out of A prime. Last thing to do is just figure out how long this side is from A to B. A to B prime. And I have my triangle. All right, now let's use this idea of side angle side congruence to solve some problems. Let's use side angle side to show that the given pair of triangles are congruent. And here I would suggest stop the video and try these on your own. So we need to find pairs side, angle, side, which are congruent in the two triangles. So let's start with side length BC, which is length 3. Looks like that's congruent to DF. And the angle is 70 degrees, that CBA. So angle CBA is congruent to angle FDE. So this is the side, the angle, and then the next side, AB, is congruent to ED. So what you have, again, side, angle, and side. And notice that the two angles that are congruent lie in between the two sides that are congruent. So by side angle side, we'll say that triangle ABC is congruent to triangle EDF. All right, next up we're going to look at these two triangles, which looks like they share a side. And this also looks like a parallelogram to me. And this is actually foreshadowing a little bit. It turns out that in a parallelogram, the diagonals create two triangles that are congruent to each other. So let's start with side AB, which we're given. Side AB is congruent to side DC. All right, and we also know that the side that they, so this is the side that they share here, this is also congruent to itself. So I'll use that. BD is congruent to itself, BD. Now it's left to show that one of these, that the angle that's included between the two given sides, the angles are congruent to each other. So I need to show that ABD is congruent to CDB. The way that I'll show that is by the given information that AB is parallel to DC. And this diagonal, I'll think of this diagonal as a transversal line cutting through two parallel lines. Okay? And notice that these two angles here are alternate interior angles. And we know that if you have parallel lines, the alternate interior angles are congruent. That was from chapter 11. So we can say that angle ABD is congruent to angle CDB because alternate interior angles made by parallel lines and a transversal are congruent. So now I have side angle side congruent to side angle side. So by side angle side, triangle ABD is congruent to triangle CDB.